Thanks a lot for joining today, and also thanks a lot for people who are watching this, for watching the recording. So today I'm going to be talking about papermill, specifically about how we can extend papermill to serve other use cases and to make it more flexible. First, a few things about me. I'm the co-founder and CEO of Plumber. We are a Y Combinator-backed company building tools, building open source tools for data science. And I'm also a former data scientist, so I encounter so many struggles with the tooling and all the challenges that we have to overcome. So that's why I decided to start the company and start building better tools for data science. Okay, so let's start with some background. We're going to be talking about papermill. So let's explain a little bit for those who don't know what papermill is. How does it work? Essentially, papermill is a package to run notebooks. Let's say you have a notebook that generates a report. Maybe you usually open Jupyter Lab and start running cell by cell. You generate the report and then you send that to somebody else. If you use papermill, you can execute that notebook from the command line. And I have an example here. Once you install papermill, you can do papermill, then your input notebook, and then the output notebook. So essentially, you're going to be creating a copy of the input notebook, and the output notebook will be like a fresh rerun of that notebook. And there are several use cases for papermill, as I mentioned before. One is a report generation. Another can be model retraining. Maybe you have a model that you have on a notebook, and the notebook trains a model, maybe tunes hyperparameters and does a few other things. You can rerun the same notebook on a schedule, let's say on Airflow or any other scheduler, and you can regenerate your model using papermill by just rerunning the same notebook. So that's what it does. Like, at its core, it's just a way to execute notebooks from the command line. All right. What many people don't know is that papermill has an extensible architecture, meaning you can customize most of what it does. And what I'm going to talk about in this presentation is the engines. The engines are how papermill executes notebooks, and they control everything about execution, meaning that you can customize pretty much every aspect of execution if you want. So on the left side of the screen, I have an example engine. And you can see that each engine is defined as a class, and it defines one class method, which is execute manage notebook. You'll receive a few parameters from here because they come from the command line, and you also receive the notebook as an argument. And inside, you run the notebook. Right? So it's up to you how you manage this logic, and papermill also offers a few utilities to make this simpler. On the right side, you see how to register a new engine so papermill can find it. Because most likely, if you are developing a custom papermill engine, you will ship this as a separate package. So you can do something like pip install papermill, then pip install my custom engine, right? My custom engine is your third-party engine, and it's distributed as a package. So if you're developing a Python package, you can create this file called setup.py. And here, you are going to configure, this is the file that you use to configure any Python package. There are other ways, but this is kind of the traditional way. And here, in one of the configuration settings, you set entry points. This is how papermill is able to recognize your new engine. So you do papermill engine, and then you have a list with a few elements. And in this, here I'm just registering one engine, which is called my engine. And then I'm telling papermill that it can find my engine in the engines.py in the class with name my engine. So that's how we do it. We create a new class, and then we register that new engine. And then we can distribute this package so that other people can use it. Now, if everything goes well, and let's assume that we already have papermill installed, and we already did pip install my engine. Then we can use the engine argument to use papermill. So we are still using papermill, input notebook, output notebook, and we are using this argument engine, and we are telling papermill to use a new engine. In this case, it would be our custom engine. All right, so now let's talk about some interesting use cases. And of course, here you can do any kind of customizations that you want, but I'm going to show you 3 use cases that we have found really, really useful for practitioners. The first one is notebook profiling. If you use papermill, the default engine, so just this part of the command, you won't be able to monitor the resources that your notebook is consuming. That's because papermill creates a second process. So this is your papermill process. And when you start executing your notebook, it will create a second process. And this second process is the one that executes the notebook. So if you start monitoring this process, you will see that it doesn't use much CPU or much memory because it's just sending the code to this second process and executing it. This is the one that's doing the heavy lifting. There's no easy way to monitor this notebook execution, and in many cases, you may want to do that. For example, if your notebook is running out of memory, or maybe you want to know if you are actually using all the cores in your computer, you may want to monitor. If you want to do notebook profiling, you can use our custom package, Plumber Engine, which implements an engine that executes everything in the same process. You can get it. It's also open source, so you can get it from here. And once you install it, you can run it with the engine argument. So I'm going to show demos for all these use cases, but I'll leave it at the end. I first want to explain the use cases, and then at the end, I'll share the demo, the live demo. Okay, so this is what happens if you use the default engine. I'm using this memory profiler package that allows me to profile memory. And on the left side, you see the result if I execute with the traditional, the default papermill engine. You see that the graph goes up and then stays the same. It's not able to monitor anything in the notebook. If I use the profiling engine, you'll see there's a difference. What I'm doing with this notebook is I'm just allocating larger NumPy arrays. So I create one array, then a few more, then a few more. And you can see the bumps in memory usage. Right, so that's one of the first use cases, notebook profiling. Okay, now, second use case, notebook debugging. This is also really interesting because if you're a papermill user, you may have encountered this in the past. Let's say that you are training a model and this model takes 3-4 hours to train, and you are executing this with papermill. If your notebook fails, it will become really difficult to debug. One of the benefits of papermill is that if your notebook fails mid-execution, you can still see the notebook. And up until to that cell, you'll be able to see the outputs, and that helps with debugging. The problem is if you forgot to print any of these variables, or maybe you have a few data frames and it's a bit hard to understand what's going on. So if you are using the default papermill engine, that's all you got. The executed notebook with the error message, and that's it. So the second use case for customizing papermill is improving the debugging. So to do that, we use debug later, which is also a package that we develop. Debug later allows you to serialize the state of the Python interpreter when your notebook crashes. It's also open source, so you can get it from here. And we integrated that with papermill. So if your notebook crashes, even remotely, so even if you are running this notebook in a EC2 machine, it still works. And that's actually the most common use case, because if you're sending something to a remote machine and it crashes, then it's convenient to have more powerful debugging tools. So it's really simple to use, and it's kind of the same idea, right? You install the custom engine, and then you pass the debug later engine. And I'll show you a little demo here. Okay, so hope looks like it isn't playing, but no worries, I'll show you the live demo in a second. Let's move on to the final use case. All right, final one. This is my favorite one because it's also because this is the latest one that we did. So experiment tracking. There are many experiment trackers for machine learning, like MLflow, but most of them require you to add custom code to your notebook and onto your scripts to log whatever you want to log. For example, you might be training a model and you may want to log some metrics, maybe accuracy, precision, recall, and maybe a few plots, right? So on your right side, I have an example. and I'm logging a few plots for each model: confusion matrix, precision recall curve, and the classification report. Now, with this custom engine, what you can do is automatically log the variables in your notebook. Not all of them. There's a way to specify which ones you want to log, because, for example, you don't want to log all the training data, right? The benefit is that you don't have to add any extra code. What this custom engine does is it runs cell by cell, and then it looks for the variables that you want to serialize. It stores all those values in a SQL database, and then you can use SQL to analyze performance, compare your experiments, have some summary tables like this, and many other things. I'm going to show you this in the demo. We recently released a blog post on this new experiment tracker, so you can look at it with more detail at plumber.io/blog/experiment-tracking. Okay, now let me share the most exciting part of this, which is the demo. Okay, so let's start with the profiling one. So let me open this. So I have it handy. Hope the text size is large enough. And we are going to be looking at the arrays.ipynb. So let me show you that notebook. Okay, so we are going to do some notebook profiling. And in this notebook, as you can see, I am creating a NumPy array with 1 million numbers. Then I'm sleeping for 3 seconds, then another array, and sleeping for another 3 seconds. So if we do memory profiling on this notebook, what we are going to see is a big bump in memory usage because of this. Then it's going to stay the same for 3 seconds, and then another bump here, right? Well, of course, we have some overhead because when we start the Python interpreter, we need to allocate some memory. So that's what we are going to see. Great. Now, let me show you what happens if I use the default papermill engine. So I'm going to do mprof. Mprof is the utility that we use to profile memory. And then we need to execute the command. So it's going to be, it's mprof run, then papermill, then arrays. This is going to take a few seconds. Okay, now we do mprof plot. And you see that it stays the same, right? It increases a bit, and then it stays the same. So we are not able to profile this notebook. Now, let's execute it again, but let's pass engine. Oh, there's a typo here. There should be profiling. Filing. Let's wait for a few seconds. And let's do mprof plot. And now you see the difference, right? In the previous version, we had a flat thing here. And now we see the little bumps because we are allocating more resources for the NumPy array. Great, so that's the first use case. Now let's go and show the second one, debugging. So let me open this one. Let me open the serial division notebook. Okay, so now imagine this is a really simple notebook, right? So I am just creating a NumPy array, actually two, one here, and then creating a matplotlib plot, scatter plot, then a data frame, and then this is where things get interesting because I'm crashing this notebook on purpose. Of course, in a real world use case, you won't crash your notebooks on purpose, but this is just so we know exactly what's going on. All right, so imagine this is some fancy notebook that we have to run on an EC2 machine. We, of course, don't know that this is going to crash, and we do papermill zero division. Let's use the default engine for now. So this is going to start running the notebook, and you see what we get here, right? We get division by 0, and then it crashes. Let's look at the output notebook. So I passed out.ipynb. Let's open it. And you see that papermill is telling us an exception encountered in cell number 5. And if I click on this, I see the traceback, right? And I can also see the outputs of the cells up until this point. There isn't anything below, and we are able to see the outputs. Now, this is convenient, but many times it's not enough. Many times we want to explore the variables, the values, and maybe run some code to understand what's going on. This is a really simple case, but in a real use case, it would be a lot more complex. So now let's see what happens if we use engine debug later. Okay, so now we see a really similar traceback, except we have this small short message at the end. It's telling us it serialized the traceback to this jupyter.dump file, and we can start debugging with this command. Okay, let's do it. So just to recap what we did, we rerun the notebook with the new debug later engine, and it created a new file for us. So now let's assume this failed on an EC2 machine, and we want to understand what happened with our notebook. Now we can run this command, dltr jupyter.dump, and then it starts a debugging session for us. So we can start printing the values of the variables. We can, let's go back to the notebook. So we have X, Y, these are the arrays. We are not printing them, right? So we don't know the values. And we also have the data frame. And those are the 3 variables that we have. Now, since we are using the debug later engine, we can do X. And we can also see the type. I think this will work. Let's see. Yeah. So it's an array. It's X, it's Y. You can print the values. And df head. So we can interactively explore the variables, and this will make things a lot easier for us to explore and to debug this notebook. Now we can do this as many times as we want. Like if we maybe a colleague of us knows this code better than us, we can send the jupyter.dump file to this person, and they'll be able to do the same thing as many times as they want. This is a really convenient way to debug notebooks that you are running remotely. Okay, final use case, experiment tracking. Let me close this. Okay, now I'm gonna be using the Python API because it's a lot more convenient. Since I'm gonna be doing experiment tracking, I want to run many experiments and then analyze the results. So I'm gonna be exporting Plumber engine and then the track execution. So first I import these packages, then this is a loop that's gonna train 45 experiments, I think. So it's gonna take about a minute or so to finish. I'll explain the code. Essentially what I'm doing is I am training many random forest classifiers from scikit-learn, and I'm changing the parameters. So number of estimators from 5 to 50, max depth from 5, 10, and no limit, and the criterion, Gini entropy, and log loss. Here, I am running all my experiments. So you can see I ran 30 so far. And my code is actually in this fit.ipynb notebook. So let me open it really quickly. It's a really simple notebook. It just generates some sample training set, the same for all experiments. I'm setting the random state here, then split between training and test, then fitting the classifier, then generating a classification report, getting the accuracy, getting a few extra metrics, generating a confusion matrix, and the classification report also as a plot, and then the precision recall plot. Okay, it's almost done. Oh, it's actually done. Yep. So now let's see what happened. What we did is this new engine logged all, and actually one important thing, we're not adding any new imports to this notebook. It's just a notebook that trains a model. It doesn't have anything like import tracker. It automatically logs the last variable on each cell. it's going to log accuracy, precision, recall, F1, and then these 3 plots. And it's sending those to a SQLite database. So let me initialize my tracker. And now I am going to run a SQL query to extract the information that I want. So the F1 score, confusion matrix, precision recall, classification report, order the experiments by F1 score. So I get the ones with the highest F1 score first. And you can see that here, right? So my best experiment had a 0.8. Well, this is actually pretty close, right? 0.8 F1 score, and I see the plots here. And I can zoom into any plot that I want. So I can do confusion matrix. And now I have these buttons that allow me to switch between the plots from my best experiment and the second best experiment. I'm going to zoom out so you can see the plot. See? I can also do a few other things. For example, since I can use SQL, I can do things like grouping. So remember, this is a random forest. I want to know what's the effect of the number of estimators in the accuracy, for example. So what I can do is I can take my experiments, group by number of estimators, and then take the mean of all of these statistics: accuracy, precision, recall, and F1. I can run this, and I get this table. Now I can generate a plot that tells me how the metrics change depending on the number of estimators. That's what I do here. And now you see that as I increase the number of estimators, my performance increases, right? Let's look, for example, at accuracy. Accuracy started as this is like 0.73 with 5 estimators. When we get to 10 estimators, this is like 0.75, 0.76. By the time we reach 25 estimators, this is like 0.77, and increasing from 25 to 50 doesn't increase performance that much. And we were able to do this really quickly because of this flexibility, right? We're able to run SQL queries, and yeah, it's really, really flexible. Okay, so that's for the demo. Now let me finish a few more slides, and then I'll open it for questions. Now, beyond papermill, we have a package called Plumber. Papermill allows you to run a single notebook. Now, in many cases, you may want to orchestrate multi-stage workflows. For example, you may have 5 notebooks, maybe for loading data, cleaning data, generating some features, training some models. In those cases, you want to create a multi-stage workflow, a pipeline. You can use Plumber for that. And actually, Plumber uses papermill under the hood with our custom engines to orchestrate the execution. Other benefits is that you can run the notebooks in parallel. So if you have multiple notebooks that are independent of each other, Plumber can execute them at the same time. You can also run them in the cloud. You can easily export your workflows to run on Kubernetes, Airflow, Slurm, and a few others. And of course, it comes with the custom engines that I explained, like profiling, debugging, and experiment tracker. And you can get it from GitHub, so github.com/plumber/plumber. And that's it. So here's my contact in case you want to ask me any questions, or you have any issues. Maybe you try to reproduce the demo. My email, my Twitter, or my LinkedIn. Now, we still have time for questions, so feel free to ask.
All right, thank you, Edward. Yeah, let's see a few questions from the comments. The first one will be: are there limitations to this debug later state storing? If this is possible, in a general sense, it opens the door to many interesting use cases, like save points in debuggers or notebooks.
Yeah, it's a great question. So we use I forgot the name of the library that we use to serialize by default, we only serialize dictionaries, lists, numbers. And if you install this optional package, then it can serialize everything. That's why when I showed the demo, it was able to serialize and unserialize the NumPy arrays. Now, that's an important question because if you're dealing with really large data sets, the dump file that it generates, it's going to become really, really big, right? So I would say the only limitation is make sure that you have enough space to store all these variables, especially if your notebook is reading large files.
All right. And that's one question. Actually, me personally, I've been working with papermill and notebook execution a lot. I've got some questions to ask if you don't mind.
Go ahead.
Um, yeah, so throughout the process of like orchestrating or executing notebooks, how would you be recommending people to like deal with the authentication process? Would that be a text stored in the notebook itself, or it could be like baked in the environment?
Authentication, you said, right?
Yeah. Imagine like you've like you have like DB connection client
Mhm.
getting spawned in your notebook or in your code, and how would you recommend us to do the authentication? Because like for a lot of firms, the text authentication was like access key, access ID is not allowed.
Yeah, that's a good point. So I would say a few things. If many of our customers use AWS and
Hmm.
they use many AWS services. So what we recommend there is to have permissions on the instances that they use. That so give the instances that run the notebooks enough permissions to access only the resources that they need. For example, when they are running these workflows in the cloud, the instance that runs the notebook has access to that specific bucket where they upload the output notebook, the bucket
Gotcha.
where they download the input data, and for example, Redshift and all those things. So it takes a lot of work to make sure that you're only giving those permissions, but I think it's the safest alternative. Now, it becomes a little tricky when you are interacting with non-AWS services, or like if you're on GCP as well, right? Like any non-GCP service. Um, I'm afraid I'm not an expert in security, um, but I could say if you are using services from the same cloud vendor, then there are ways to authenticate those instances and those containers only with the permissions that they need.
Gotcha. Hence, do you think there's any like possibilities for open source projects to be working on those orchestration with authentications, or that could be locked into the vendors?
Well, I think there are many cases, right? So I feel like definitely authentication is a problem. So there might be ways to simplify it. But there are in enterprises, there are so many different configurations that it becomes really hard to come up with a generic solution.
Gotcha. Yeah, that's a very inspiring talk throughout the whole session. Like me, again, I personally work on those sort of issues a lot. Yeah. Let's see if there's any other questions on that. I don't see any at this moment. Um. Hmm. All right. I think that would that be all for your session as of today?
Yep.
All right, cool. Glad to have you. And we'll be moving on to the next topic. Have a good day, sir.
Thanks a lot.